Lesson 3-2. So before I get going on this, I'm going to show you there are, for exponentials, that's what we did in lesson 3-1. There's a formula chart and a calculator I created for you, and I want to make sure you know where those are. So I'm about to use these in a second, but I'm going to just walk you through how to get to them. From a Google Classroom perspective, if you log into your Google Classroom and you click on classwork, I have listed your formula chart and the Desmos graphs right next to one another, and the daily, weekly links right up at the top. If you go here, the formula chart for exponentials, there's two formulas in particular that we'll use often. I'm going to scroll down and show them to you. Under exponentials, I know there's 5 listed on this ACP formula chart, but the 2 you actually need to be successful in my class are these 2 middle ones right there, the ones that say compound. So compound interest and continuous compound interest. Those are the 2 that we use. The bottom 2 underneath, as we get going through this chapter, you're going to learn that these variables, these are the exact same formulas. It's just the variables they use are different. But it's the same 2 formulas. The math works the same in them. So just to make it simple, I only use these middle 2. The top is something from like easier math than pre-calc. So we don't. This one's too easy. These 2 are just the same. So these are the 2 I'm going to use right there. Any questions on the formula chart? So I'm going to copy those down because we're going to use those here. We'll have to determine which of these 2 formulas to use. So I have A equals P times 1 plus R divided by N raised to the power of NT. And you will also have the formula A equals what I call PERT. In that box, there should be one. And that's the second formula. Now, for a lot of your calculations, I would recommend you use the Desmos pre-programmed graphs. So if you click this link, what comes up right away is this chart that just lists the pre-programmed graphs that I have available right now to you. And this is compound interest number 6. So I'll go ahead and click that to have it open. You would use that. Now, if you wanted to see all of this, what I just showed you from PowerSchool Learning perspective, let me get to your class. You would go to chapter 3. And in chapter 3, you'll notice I've added them and I put it in a different color blue so it stands out. On lesson 3-1 is where they start. I'm going to add them to all of them. I haven't gone through yet and done so, but it will be there soon. On 3-1, you can see in different color blue, I have a click here for the pre-calculus formula chart. Click here for the list of pre-programmed graphs. I put those in as well. So the formula chart is part of your digital resources. And the Desmos I did for with the homework link. That's where I figured you'd be using that at home. So, any questions on that? Let's go actually solve the problems. So we got a calculator up, and we're ready to go. It says the number of downloads of a new song grows at a continuous exponential rate during the first days of a song's release, as shown in this table. What is the song's growth rate during the 10 days? Okay, so we have to determine what the rate is. We're looking for the R. As you can see, both these formulas have an R. So which formula are we going to use? It comes down to the terminology. You use the top formula if you're told a certain number of times per year. So if you see a word like daily, which means each day of the year, if you saw monthly, which that would mean 12 times per year, there's 12 months. If you saw weekly, there are 52 weeks in a year. If you saw like annually, that means once per year. If you see any of these type words, you would use the top formula. The way I also sometimes will say it is a key word is if you see per. The word per, because typically it'll say something per year or whatever. Per is a key word for the top formula. Now, in the word problem, did you see any of these words that I just mentioned? Daily, monthly, weekly, annually? You see that anywhere in the problem? No. Okay, so it's probably not that formula. Now, if you're going to use this one, if you remember on the formula chart, they called this the continuous. There's 2 words you look for. You look for either the word continuous compound, That's continuous you'd be looking for. The other word you look for is what that E stands for. E stands for exponential or exponentially. So you'd be looking for continuous or exponential or exponentially. Okay, do you see any of those words?
Continuous exponential.
Yeah, there's both of them right there. Which means this problem, if we're going to solve it correctly, we need to use what I call a PERT. A refers to the final amount. So when I look up at the four values, the final amount is the 12,150. So this is my A. P is the initial amount. So that would be the 300. We don't know R. That's what we're looking for. E, by the way, if you didn't catch this in lesson 3.1, E is like pi. It's a number. It's 2.71, something. It just keeps on going on. I'll do a squiggly equal signs because it's not exactly 2.71. But E is a number, so you don't have to solve for E. R is what we're looking for. T. Now, and there's two different T values, 0 and 10. Time is like how much time passed by to get to the final amount. Answer would be 10. It took 10 days to get from the initial to the final. So that's our T there. So if we wanted to solve this, you'd be solving the equation if you plugged everything in. 12,150 equals 300 e to the r. We don't know what r is, but we do know t is 10. That's the equation you'd be solving. But as I told you a moment ago, I created a Desmos graph for you, so you don't have to type all this in to solve. So how does a Desmos graph work? On this, you first, step one, you have to select which of the two formulas we're going to be using. This, if you go through Google Classroom, are you Google Classroom or, okay. If you go to classwork, it's right there in the daily, weekly links. Right at the very top, you'll see Desmos pre-programmed graphs. If you click that up, it'll open up a list, choose compound interest. Okay, which of the two formulas are we using? The one with the N or the PERT? For number one.
PERT.
PERT. So click this circle on the left. That's what the first instruction says. Secondly, we need to plug in our values. So the A was 12,150. The P was 300. The rate is unknown. Now what this instruction says right here, if you have something that's unknown, set it equal to X. So I'm going to put that R equals X. And T we said was 10. Now in our problem, we don't have an N, so you don't have to worry about that if applicable part right there. The way you find your solution is you take your y-axis to this amount right there. That's where the intersection will be. Our answer is going to be where at 12,150. So I'm going to just scroll on up, and you can see right there, I have an intersection, 12,150. The answer is 0.37. That's the growth rate. So back on our problem, the answer to this problem would be a growth rate of 0.37. R equals 0.37, which is the same thing as 37%. That's your answer. So this equation, if you were going to put it back in its form, they actually use N of t, so I'll say N of t at the front instead of A, that the number of downloads would equal 300 e to the 0.37 time. That would be the actual equation, is because for however much time takes place, you can figure out the number of downloads using that formula there. Okay, and now number two. Now, hey, before I do number two, so the point of exponentials is the way things work in the real world is not always linearly. So like something that is linear, if you're working a job that pays you $8 an hour, that's linear. You know that if I work 4 hours, I'm going to make 4 times 8. I'm going to make $32. That's linearly. A lot of the big things in life that you really want, it's unfortunate we don't spend very much time dealing with exponentials because a lot of them either can be afforded faster or can take advantage of you quicker because of exponential equations. this is the way much of life works. If you ever go buy a house and the house costs $100,000, do you think you'll actually pay the bank $100,000 by the time you're done? What do you think? Do you think you'll pay them that much or more or less? More. Why do you have to pay them more? Interest. It just keeps building. That's what's all these formulas are finding out is the growth over time. So in this particular example, someone releases a song, and at first you might not have very much of a following. So only like 300 people are listening to it. But if they really like the song, what are those 300 people going to do? They're going to listen to it more. What else are they going to do? What do you do when you have a band that you really like here at school? Or you listen to them, you really like them, and you're at school. What do you do with their friends at school?
Sure.
You share it. And so they start listening to it. And what do? They share it with their friends. And the more friends, the faster it gets shared. And it grows quicker and quicker. It's not linear, it's exponential. And so that's how this growth looks like. And let me show you the picture. As you can see, if I zoom out, this graph, let me just change my, let's go from -5 to 10 here. And I'm going to show you from -2,000 to 15,000. As you can see, this graph isn't linear. You see how it just curves up? That's just because it's like, at first you don't grow very fast, but as certain people start to find out about the music and start to share it, as you get a bigger and bigger following, the downloads grow a lot faster. That's the idea with exponential, okay? So now let's try one that revolves around money, because this is where exponentials come into play. So important for your life. If you ever want to buy a car, a house, college, expenses, stuff like that. Let's take a look at number 2. It says the Martinez are saving for their son's college education. If they deposit $31,500 into an account earning 7.6% per year, compounded monthly, approximately how many years will it take for the value of the account to reach $80,000? Okay, so remember from the formula chart, there's always going to be 2 formulas you have to decide between. Is it compound interest formula, the first one on the left, or is it continuous compound interest, the one on the right? Which of the 2 formulas do we need to choose, the continuous or the regular compound for this particular problem? Why?
Because it says per year.
Per is a key word. If you see per, you're thinking probably the first, and it should give you one more word to make sure it's very clear. It should tell you how many times per year.
Monthly.
Monthly. Now, how many months are there in a year? Whenever you do the per, you have to think about how many in a year. So how many months are there in a year? 12. So in this problem, n is 12. Which I write that down in the Desmos calculator. I'll show you in a second. So we know n is 12. What's this 7.6%? That's the rate. So let me start. I'll do an order. What's our final amount? 80,000. Okay, so 80,000 is going to equal, what's the initial? That's the final amount right there. What was the initial amount?
31,500.
That's the P. So basically, a family has 31,000. That's how much money they have stored up in a bank. Or actually, it's not in the bank, it's in an account. We want it to grow to become 80,000. We're going to see how long will it take for it to grow that much. So it's got to over double. And I'm going to go parentheses 1 plus. The rate is 7.6%. If you don't know, the way to get rid of percentage is to divide by 100%. And that was supposed to scratch those out. That was ugly. But that would leave you with 0.76. It moves the decimal 2 times. Is what happens. 1, 2. So that's our rate over the n of 12. And this will be 12t. So there's our equation right there. That's if you were going to solve all this by hand. If the apocalypse hits and you have no more Desmos, no more Mathway, how are you going to solve this? You'd have to solve that by hand right there. But apocalypse doesn't hit, so I'm going to come over here and use Desmos. Am I using top formula or bottom formula? Top. So I'm going to light that one up. I'm going to turn off PERT. We'll type in our values. The final amount is $80,000. So we want our money to more than double, and we don't want to have to work for it. We don't want to have to go work an hourly job. We just want the market to earn this for us. If it makes 7.6%, that's 7.6 divided by 100. That's what I did earlier. You could type it in like that if you didn't want to do the math. You just type that in for the rate. But we don't know how long it's going to take. That's going to be our X. Now on this if applicable, here's what I wanted you to know. We know that months, there's 12 months in a year, so we already know it's 12. But if you did not know that, I have listed, I programmed in the ones that I think you might see, and I put them in order. Annually, semi-annually, quarterly, monthly, weekly, daily. I put them on there. So they're on that list just to tell you, depending on the word you use, what to set n to be equal to. Now I go up, and I'm always going to look for the crossing at the A amount. So this is going to cross at 80,000. So I'm right now, I can only see that. I'm going to raise it up. The quickest way is I'm going to hit the settings. I'm going to change my Y to be bigger than 80,000. I'll put in 90,000. So now I can see how long it takes for these to cross. It looks like my graph crosses at 12.302. That's the X value. Oh my goodness. Zoomers, you been able to see what I've been sharing?
Yes, sir.
Okay, it says it's paused.
Yeah, we can see it.
Okay, so it's just fine. I thought it crashed out on me. The answer here is 12.32 years, 302 years. That's how long it takes for your money to double.